Hello and welcome back to the Coder's Legacy channel. In this video, I'm going to be showing you this framework. Hello and welcome back to the Coder's Legacy channel. In this video, I'll be introducing you to this framework called ExLlamaV2 that is used for LLM inference, training, fine-tuning, etc. This is a really great framework. I've used several LLM frameworks and this is the one that I found really great, and I'm also using it in a professional environment, in production environments. It's very good, very stable, and what the main thing is about this is that it's very fast. It's arguably the fastest framework there is at the time of this video. So let's get right into it. Let me explain how to use this framework. I'm going to make a whole bunch of videos on this framework because it's too vast, too many cool things, features to discuss. So this is just going to be a basic video, how to set it up and how to run the basic scripts. Okay, I have a completely fresh environment here that we're going to be using. Okay, so what I'm going to do first is set up a requirements.txt. We're going to copy the requirements from the GitHub. So just follow along. You go here. I'll leave a link to this in the description below. Just go here, copy the requirements, paste them in here, and just install them. Okay, so that's done, but there's one more thing we need to do. First of all, ExLlama at the time of this video does not support CPU inference. Hopefully that'll be fixed soon. I expect that to be fixed soon. So what we're going to do is get PyTorch over here with the GPU version. Okay, so I'll install this separately. 1 second. Okay, yeah. Alright, so that's done as well. And there's one final thing we need to do. Go here to releases, okay, and then open this and go here and select the correct version that corresponds to what you have. Now here is what I have. I have the environment with Python 3.12 and I have Windows. See Win over there. And hold on, there's more. There's a Torch 2.6, which is what we have, and we need to look for the correct CUDA version. Okay, here we are. CUDA 12.4 is what I downloaded. Python 3.12 and Windows. Perfect. So we're gonna copy the link here, go over here, and by the way, you can also do pip install ExLlamaV2, but that just downloads the CPU versions of the Torch libraries. So I just like doing this manually, you know, copying the files and requirement.txt file and then installing Torch and then installing ExLlama like this, because when you do it like this from the release page, then you get the CUDA version. So yeah, alright, so now that's done and we can finally get started. So we're just going to be running some scripts because let me just show you. There are a bunch of nice examples over here in ExLlama examples folder, and we're going to be running a few of these. First one we'll run is this inference one over here. Okay, copy the contents, and essentially this is kind of to check that everything is working just fine. I'll explain the code in a minute. Let's just try and run this. Oh, okay, so I forgot to mention this part. Give me a second. Alrighty, done. So what you need to do actually is download a model. Now ExLlamaV2, it supports two different types of quantizations, or three different types of models. One, you can download a unquantized model, alright, a native model without any compression, or you can download the XL2 format or the GPTQ format. Well, we won't go into GPTQ because it's a bit of an old format, and XL2 is basically a format introduced by ExLlama. It kind of comes from the name ExLlamaV2, so XL2. I think that's how they came up with the idea for that name. So whatever. You go to this guy over here, TurboDerp. He's the one who, you know, created the repository. So he has a bunch of quantizations for his library. For all of these are popular XL2 quantizations for various models. And the great thing about the XL2 format is that first of all, it's very accurate. It's generally higher than better in accuracy compared to similar quantizations. And the most interesting thing about it, though, like for example, open up this, Llama 3.2 billion, 3.23 billion. So the ExLlamaV2 format allows you to download the model in variable number of bits. Many quantization methods are restricted to a single bit, like 4 bits or 8 bits, or maybe just 2 or 3 options. ExLlamaV2 is a format that allows you to use models in many different bits, as you can see right here. Very convenient. So I've already downloaded this one, the 5-bit version, and I have that downloaded over here. You can download this by just going over here. It's kind of irritating, but like just download each of these files manually and copy them here somewhere. So I'm just gonna copy this path here. There we go. And let's run this code. Alright, so this is where another error comes up, and I know what this is. Let me just see where exactly it is. Okay, so I think paged attention is on by default, and I will disable this for now. We'll come back to this later in a separate video, because this is a concept that requires like a 5-10 minute explanation for you to truly understand how this works. Alright, there we go. So now it's running. Single completion. What is this? It's giving us a story, kind of. Yeah. This gave it 4 inputs in like a batched format. That's also another great thing about ExLlama. It's designed for speed. It has batching. It has a bunch of other things that we'll go into soon. So we gave all these 4 prompts at the same time, and this obviously increases the throughput for our inference. So this is it. This is how we just generated all this text, and it also provides a lot of logging methods with which we can check the speed. There's this timer. We can use that, and you know what? We're getting ahead of ourselves. Let's start from the very beginning. Okay. So first of all, we have the imports. Nothing much to see there. Then what we have is the configuration. Again, there's not much here. The config, you don't need to worry too much about that. Just pass the model there to it. Okay, now over here is where we initialize the model. Again, there's not much to do here. The real stuff comes over here. The cache. The cache is a very important component in ExLlamaV2, and it's basically what it does is pre-allocates. Basically, you know if you ever used other frameworks before, what happens is that they use your RAM, your GPU RAM, VRAM as it's called. Let me show this to you. So you see here that I have a 4090 in this CPU, in this PC. It has 24 GB of GPU memory. Now, for example, this model is going to take about 3 GB of memory. So when this model loads, it's going to take about 3 GB, so we'll end up with about 3.7 GB. But then during inference, it also requires additional GPU memory because of the tokens that it generates and everything. So it typically requires a few extra GB. So what ExLlama does is that it pre-allocates that space. Because what happens in other frameworks is that you have, for example, 8 GB of VRAM, and then you load a model of 8 GB. Okay, so you're break even, and then you run inference. So at runtime, your model can crash. Get it? Or for example, you have 8 GB of VRAM, but you load a 6 GB model, but then you give it a very, very big text document, and then it'll crash. So these are issues that can happen. It's going to crash because, of course, it's a very big document, so when it converts to tokens and when the computation happens, then it requires a lot of space, right? So what ExLlama does is that to avoid such things, to avoid crashes at runtime, it pre-allocates that space. This means 32,000 tokens. It pre-allocates enough space for 32,000 tokens. And what this means is that the input tokens, for example, what this means is that we could have a 30,000 token input and a 2768 token output. Or what we could do, we could have like 5,000 plus 1000, 5000 plus 1000, like this. We could have many inputs at the same time in a batched format, as long as the sum of this is less than 32768. Okay, so what the cache does is that it ensures your program is not going to crash after it has initialized. Next up is load auto split. Okay, so let me explain how this works. Now, what this does is that if you have a very big model, like say you have a 30 GB model, okay, that you want to load, but you only have 24 GB of VRAM, like I do right now, so it's not going to fit, right? So what instead you can do is take two GPUs, like two 4090s, and then you can split. This does it automatically. That's the great thing. It splits the model. It splits the GPU across the Alright, so next up is load auto split. This is again a really handy feature of ExLlama, where it basically splits your model across several GPUs if it turns out that it can't fit on your GPU. So if you have a 20 GB model and you have 16 GB of VRAM, then that's not going to fit. It's going to crash immediately. So instead, what you can do is get two GPUs, two of the same GPU, and then this will automatically split it. It'll first fill up the first GPU, and when it's full, it'll go to the second one. So that's how this works. And this is the tokenizer. The tokenizer is the thing that converts your string. For example, if you give the LLM the word hello, the tokenizer is going to convert that to a number like 300, and then it's going to give that to the LLM. So hello world, for example, might turn into something like this, where 300 represents hello and 120 represents world. Because obviously the LLM doesn't understand strings, it understands numbers. So that's the job of a tokenizer. Okay, so this is the dynamic generator, which is basically the thing that kind of like brings the cache, the model, the tokenizer, it brings them all together and gives you the interface to do inference. We'll ignore this parameter for now, we'll come back to this later. Okay, and now that I think about it, we can't even use this parameter in Windows because flash attention isn't supported. So unless you're on Linux, this parameter isn't going to be helpful for you anyway, so don't worry. Anyways, max new tokens, this is the number of tokens that you want to generate. Like you give it 1,000 tokens input, for example, and max new tokens is going to decide how many tokens you will let the LLM generate in response to your input. And when you pass multiple prompts, by the way, max new tokens is basically going to be 250 for each one of these prompts. Okay, so in total, you'll be giving the generator, the LLM, 1,000 tokens to generate. But that's the maximum. Okay, it may not necessarily generate 1,000. Okay, it may generate 100 per prompt. Okay, and warm up is nothing important. It just it's a common thing in LLMs that the first pass, that the first inference always takes longer. So we just do a slight warm up over here, to basically get that first inference out of the way, and the preceding inferences are going to be much faster. And yeah, then that's our generation. Yeah, okay, I don't know why, but this example had like two separate generations, one over there, and then a batch generation. Oh, okay, I guess they were just demonstrating the difference between a single generation and a batch generation. Okay, that's cool. There's not much else to show you guys over here, except one thing. Because one thing that looks kind of weird right now is that the input is incomplete, right? So let me just explain why that's happening and rectify that in front of you guys. And then we'll wrap this video up over there. So go back to the examples. There's something I need to copy from here. The get stop conditions. Because currently our LLM is generating non-stop. We did not tell it to stop. There's a parameter here called this one, stop conditions. We need to copy the whole thing. So I'm gonna paste that in here. Okay, what's wrong now? Okay, cool. So we need the prompt format. The prompt format, let me show you. We can just write the string out here, but yeah, so the prompt format, that's it. I'll show you where the prompt formats are. They're here somewhere. They're in the util.py. Here they are. Here are the different prompt formats that Llama, the ExLlama has: Gamma, Granite, and Llama. Right? And get stop tokens is basically just this. Nothing complicated. Basically, a stop token tells the LLM when to stop, and if you don't give this to the LLM, it's never going to stop, which is what's happening right now. So yeah, that's pretty much it. So once I pass this parameter, I just need to make the import for it. Okay. Oh wait, that's from the repo. So what I'm gonna do instead, I'll just not make that import. We don't need to do that really. What I'm gonna do instead is, and what you guys will need to do as well, by the way, don't think it's just me, I'll just copy these two functions because that's what we want. I'm gonna paste that over here in the util file, util.py, or you can paste them into your own code file. It really doesn't make a difference. I'll just undo that import. Okay, we can keep that import over there. We need to do the format prompt thing as well, actually. I don't think we don't need to do that. Let me just see how they were using it over here in the CFG file. Okay, so the thing is about a prompt format is that exactly what it sounds like over here, really. You need to give the LLM the input, the prompt, in the same way that it was trained. Which basically means that when you train LLM, you don't just train it on raw text. You give it tokens, like these special tokens that mark specific things in the text, like the beginning of the text, the start of the system being the LLM, then the start of the user, then the start of the assistant. The system here is like the system prompt, which basically contains the text where the LLM, where you define what the LLM is. You tell the LLM that, hey, you are a helpful assistant, for example. In the user, this is where the user's query goes. Like you ask a question or something, for example. The assistant is basically the LLM and what it says in response. See, the system has the system prompt over here. The user has the user prompt here, but the assistant doesn't have anything. There's nothing that comes after the assistant. And that's because that is what needs to be generated. That's what the LLM is going to generate and give it to you. We're essentially leaving this blank, kind of. And we're telling the LLM, now it's your turn. We're first telling it what you are, then we're telling it what we want, and then we're telling it that it's your turn to talk. Okay, so I'm gonna copy this prompt format. This is a bit irritating, having to do this. I'm just trying to get this quickly. What I need to do is go over here, and we'll just do this for the batch generation. We'll paste this as a system prompt. Okay, system prompt, and then copy the format. Wait, what am I doing? We don't need to do that. We just need to do something a little redundant over here. There we go. Anything else? No, we're good. So I'm gonna run this one more time, and this time we'll get some properly formatted responses. Oh, come on, what's wrong with you? Okay, remove that. Copy the wrong import from there. Let's just take a look at the memory, because you can see it takes about 8 GB. So any of you guys can run this. It's a 3 billion model, 3 GB model roughly, and it has a cache size of 32,000. So by the way, like 8 GB was being used, about 0.7 was being used by the Windows operating system itself, and then about 3 GB by the model, and then the rest was being used by the cache. Okay, so we know it's working, and you know why? Because, for example, take a look at this batch completion number 3. This is the input that we gave it, okay, and this is the output. It didn't generate 256 tokens. That's not 256 tokens. That's like maybe 30, 40. So it stopped, okay, because we gave it the stop conditions, and it's returning the output in this format because that's the way we formatted the input. Now I know it's annoying to get this in the output, so what we're gonna do is this: completion is equal to true. Completion only is equal to true. And what that's going to do is only return the output, only return the generation part. There we go. Wait, sorry. That's a single completion. This is it. This is what we're interested in. See? It's only the output. And with that, the first video for ExLlamaV2 is concluded. That went on way longer than I thought it would, honestly, because there's just so much to cover. And I have more things planned to discuss with you guys, because there's a lot of complexity here, a lot of inner workings and stuff that you need to know if you're working with this library extensively or in some critical environments. So I'm going to be sharing those things with you guys in the upcoming videos.